All right, so this week we're going to take a look at two formulas. The first one is law of sines. The second one is law of cosines. Both of the formulas are used to figure out the sides and angles in a triangle. Now we've done that before. Does anybody remember when we found sides and angles, we used like opposite over hypotenuse and all that? What kind of triangle did we always use? Yeah, we always had a right triangle. When you have a right triangle, you can use Pythagorean theorem. That works fine. You can also use the SOHCAHTOA. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. When you don't have a right triangle, you don't have a hypotenuse. So that means you can't use Pythagorean theorem. So what do we use? I'll show you. First of all, a triangle that does not have a 90-degree angle, that's called an oblique triangle. There's two types. Which type we're working with, that doesn't really matter. I'm just showing you there are two types. One type is called an acute triangle. Think of like an equilateral. All the angles are 60. They're all smaller than 90. The other kind of triangle you can have that doesn't have a 90 is where there's one angle bigger than 90. Could you have two angles bigger than 90? No. Because they have to add up to what? 180. Yeah. So even though we don't have a 90, they still have to add up to 180. Yep. So for each problem we do, we're going to draw a diagram. Does anybody remember when we did the diagram 2 weeks ago, the week before graphing? What letters did we always use for the sides?
A, B, C.
Yeah, we always used an A, a B, and a C. And we used Greek letters for the angles. Does anyone remember what the angle across?
Beta.
Which one was across from A?
Alpha.
Alpha. And across from B?
Beta.
Beta. The one across from C, we never gave a name to it. The reason we didn't give it a name is because it was always, well, the one across from the hypotenuse was always
90 degrees.
90 degrees. So we just called it the right angle. This week, this angle,
It's the wrong angle.
yep, it's not a 90. And that Greek letter is gamma, G-A-M-M-A. So the diagram is pretty much the same. It is the same for the sides, A, B, and C. Alpha is across from A, beta is across from B. That's the same. Just make sure we put gamma across from C. When I draw my diagrams, they're not necessarily to scale. What is important is you just keep A and alpha across, B and beta, and C and gamma.
What's that called again?
Gamma. It looks, I draw it a little bit bigger, it looks kind of like this.
That's so weird.
All right, so there are two laws we're going to look at, law of sines and law of cosines. We can only use the law of sines to do certain things. Okay? We can only use the law of cosines to do the other things. So what can we use law of sines for? Either one of these two types of problems, they could give us these three pieces of information and ask us to find the three pieces we don't know. Pretty much every problem that says solve the triangle, they will give you three things, and then you have to find three things. These three letters are used to describe what pieces of information you're given and where it is. Both of these, they give you two angles and a side. The difference is, where is the side? Is the side between the two angles? Like in this one, you have an angle up here, an angle down here, and the side they gave you is the one that connects them. It's the one between. For this one, the side that connects them is the bottom one. They didn't give you the bottom one. They gave you the side that's not between the two angles. Either way, it doesn't matter. We're still going to use law of sines. All right, so there's two cases that we're going to talk about today. And there's one more. Two sides and an angle. Okay, so well, what's the difference? Well, the difference is the bottom one is two sides and an angle. The top ones are two angles and a side. And specifically, when they give you two sides and an angle, the angle cannot be between the two sides if you're doing law of sines. In this case, the angle that's between the two sides would be this top one. It's where the two sides meet. It's between them. In our problem, they gave us an angle that's not at the top. So that's called side angle. When you write the abbreviation, you can write like angle, side angle. If you write it backwards, well, that one's the same. For side angle, angle, you can write angle, angle, side. That's the same thing. And for side angle, well, we're going to leave it in that order. It's not nice if you reverse it.
Wait, why does that one not work if you reverse it?
It's a bad word.
That's true.
Yeah. So I'd rather you leave it in that order when you write your answer on the test. Otherwise, I'm going to think you're calling me a name.
I would never.
I would never call you a donkey.
All right. So again, order here on the top two, though, it doesn't matter. Same thing. Okay. So those are the three types of problems that you can solve with law of sines. Those three. The two that are not listed there, they're the only other two types that we're going to learn, are side, because you cannot use this formula, it won't work, and SAS, side, angle, side. This formula doesn't work for that either. And if you're like, oh wait, I could make up another one, what about angle, angle, angle? That's impossible. We can't solve that problem. It's like if I said to you, I'm thinking of a triangle, and the angles are 60, 60, and 60. What kind of triangle would that be?
Equilateral.
It'd be equilateral, and then if I said, okay, how long is each side? Well,
The same as all the other sides.
yeah, you don't know. 2, 2, and 2, or 7, 7, 7. You got to have at least one side. So angle, angle, angle is impossible.
Can you solve with side?
Yeah, side is the other one we're going to learn about on Wednesday. Yeah.
Cool.
Side is doable, just not with this formula. It's with the law of cosines, not the law of sines. All right. So let's look at the law of sines. So right now, we know how to work with what kind of triangles? Or at least I taught you how to work with what kind of triangles a couple weeks ago. Right triangles. So what we're going to do is we're going to try to use what we know about right triangles to figure out a formula for this triangle. Okay, there's no 90-degree angle in that triangle. Or at least it's not supposed to look like there's any. For what I'm going to do, I do not need to label all of the sides. You can if you want. I don't need the bottom side, and I don't need the top angle. Okay. I'm going to separate that into two right triangles. And that's a 90 right there. Do the two right triangles look the same?
No.
No. I think the one on the right is probably bigger than the one on the left. So they're not supposed to look the same. Okay. I'm going to call this third side the height. Okay, so that's h for the height, not hypotenuse. Okay, so any questions on what we've labeled there? A is across from alpha, and B is across from beta. All right, so what I'm going to do, we're going to block the right-hand side for now. Just going to look at the left side. All right, so I want to look at that triangle that's there. I've got three things, 1, 2, 3. And I want to come up with a trig function that's going to relate those three things. To figure that out, figure out the position of these two sides. What position is side h relative to alpha? It is opposite. Yep. Okay, so that side is opposite. And what about side B? That is hypotenuse. So out of the three trig functions we use, sine, cosine, tangent, does anybody remember which one has opposite and hypotenuse? One of them has opposite and adjacent. One has adjacent and hypotenuse.
Cosine.
And the other one is opposite and hypotenuse. If you think of the Sakatella, that might help.
Oh, yeah.
Yeah. Sine is the one with opposite and hypotenuse. Yeah. So that's the one we're gonna use. And since, we're proving something about the law of sines, probably gonna use sine. So it would be the sine of my angle equals, and what would be my fraction on the other side? What would go in the top?
Opposite over hypotenuse.
Opposite over hypotenuse. Yep. Okay, now I want to get a formula for h. What's preventing the h from being by itself right now on the right? The b. So I want to get rid of the b.
Times it.
So what are we doing with the b right now if you just read what's there? We're dividing. What operation cancels division? Multiplying. And what would we multiply each side by? B. So when you divide by b and you times by b, that's gone. And what do I get for a formula for h?
B times
Yeah, b times what?
sine alpha.
Sine of alpha. So that's a formula that calculates the height of the triangle as long as you know that side and that angle. It's going to give you the height. Any question why that formula gives you the height?
No.
All right, now we're going to do the same thing again. This time, I'm going to look at that side. All right, so we're going to look at these three pieces of information. And first, we're going to label which side is where. What's the side that's across from beta called? Or what position is it? It's still opposite, same as it was before. It's opposite beta. And what about side A?
The hypotenuse.
Yep. That's across from the 90, so it is the hypotenuse. Okay. What trig function has opposite and hypotenuse?
Sine.
Sine. Okay. This time it's going to be the sine of
Beta.
this angle. And what goes in the top and the bottom?
H over A.
H over A. Now, just like I did before, I want to get a formula for the height. How would we get A on the left side?
Times it by A.
Times by A. Times by A. And what would go in that box?
A times sine beta.
Yep. So that is another formula to find the height if you knew this angle and that side. So it's a different way to find the height of that triangle. All right, now let's look at both of them together. So I'm going to call that one box 1. Call that one box 2. What is box 1 equal to?
H.
H. What is box 2 equal to?
H.
H. So what does that mean about box 1 and box 2 then?
They're equal.
They are equal. Yep. Box 1 and box 2 equal each other because they're both equal to the height. So let's write that down. I'm going to do box 1, b sine alpha equals box 2, a sine beta. Now there's one step left, and then once we do that, the formula we're going to have is the law of sines. So I want you to kind of see that the law of sines really comes from working with two right triangles and combining what you know about them. That's where it comes from. All right. When they write the law of sines, they usually put the A over with the alpha. We've got a times A. How would I move the A over to the left?
Divide it.
Yep, I'm going to divide by it. And they usually put the B over with the beta. So how are we going to move the B over to the
Divided
right?
by B.
We're going to divide by B. When you divide by A on the right side, it cancels. When you divide by B on the left side, that cancels. So you are left with this. Sine of alpha over A equals sine of beta over B. And there is one more fraction here. It follows the same pattern as the first two. We didn't prove this one. But looking at the first two, anyone think they know what the third fraction would be?
Sine of alpha, beta.
Would it be gamma?
Sine of gamma
Over
Yep.
C?
over Z. That is the law of sines. I think I wrote that at the top. Okay. So when you are using the law of sines, it has three fractions in it. You never use all three at the same time. You only use two. You can use the first two, you can use the last two, or you can use the first one with the last one. And again, we didn't prove where this third one came from. It would be going through and doing the same thing we just did again with this triangle, but drawing in this from a different side. Okay. So I just wanted to prove it for the first two. Okay. Any question on this formula? When you use this formula, since you're going to pick two fractions, you're going to have four things. 1, 2, 3, 4. Top and the bottom on the left. Top and bottom on the right. Out of the four spots, you need to know three of them. The fourth one is going to be the one you don't know. So it's going to look, if I didn't use trig, it would look something like this. You're going to have four spots. Three of them will all be numbers. One of them will be a letter. Now, from Algebra 1, does anyone remember how you solve this is a proportion? What you do to solve a proportion? Only when you're adding and subtracting fractions.
Can't you cross
So you don't have to worry about any common denominators.
Cross multiply.
Yeah, you would cross multiply. So like in this one, this doesn't have any trig in it, but it would be like 5 times 2 equals 3 times x. And then you divide each side by 3. Yeah. That's pretty much what every law of sines problem is going to be like. You're going to cross multiply and then divide. Yeah. So the way we'll kind of set everything up, first we'll make a sketch. Okay, and the sketch, that's just going to help us to know what kind of triangle you're working with. So we'll make a sketch, and then we're going to put all our data in a table. The table is going to look just like this. Does that remind you of anything we've done before?
Yeah, the cosine.
Yeah, when we did the cosine, the tangent, all that stuff. And then this third one right here, this was always the right angle. Well, this week, it's gamma. Okay, you will always be given 3 out of the 6 pieces of information. Then you have to find the other 3. So Pythagorean theorem, nope, can't use that because unless you know you have a 90. Okay, if you know your problem has a 90, then you can go back and do it the way I taught you 2 weeks ago. But I would expect most of these to not have a 90. So you can't use Pythagorean theorem, but you still know all the angles add up to what in a triangle?
180.
Yeah, and that's what I wrote right here. So that's still true. add up all the angles, they still have to add up to 180. All right, so as far as kind of explaining the formulas, that's it. That's the formula you need to know for today and tomorrow. So I'm going to try to go through one example of each type. Okay, we'll do one of the side-side angle, angle-side angle, and side-angle angle. These two are pretty straightforward. This last one, we're going to talk about it today, and we'll finish talking about it tomorrow. Because this one has a little bit more going on. But the top two are pretty straightforward. All right, so let's try this one. Okay, so they gave us 3 pieces of information. Alpha is 40 degrees, beta is 60, A is 4. What's the first thing we want to do with all of that?
Put it into a chart.
Yeah, so we can put it into our table, which I've done for you right there. And the other thing we want to do with this information is what? You can either make the chart first or you can do this first.
Draw a triangle.
Yeah, let's just make a triangle out of it. Okay, I always draw all my triangles that way. Again, it's not to scale. If I put A on the left side, what angle is going to go down in the lower right? Which one? Alpha. A goes across from alpha. Let's put B on the bottom. So now where would beta have to go? It'd have to go up at the top. It's got to go across from it. And that only leaves C. And what do we call the third angle? What is it?
Gamma.
Gamma. All right, so now look at your 3 pieces of information. Using 3 letters, okay, A and S, those are your letters, what kind of triangle is this one?
Angle, angle, side.
This is angle,
Angle.
angle, side. If you're wondering why isn't it angle, side, angle? Well, you'd have to know C for that. That's the one that connects them. 4 is not between the 2 angles, so it's on the outside of them. If you wrote side angle, angle here, that's okay too. Okay, you can write it either way. But the point is, it's angle, angle, side. If you go back in your notes, angle, angle, side is one of the 3 types you use law of sines. Okay, so let's do that. All right, what do you think we could find first?
The third angle.
Yeah, we could get the third angle. Anytime you've got 2, you can add them up and subtract from 180. What's your
Wouldn't it be
third
80?
angle?
It would be 80.
It'd be
So you
80.
take 60 plus 40 is 100.
Yeah.
And then you subtract that, so it would be 80.
It'd be 80. Now, last week, once we found a piece of information, what did I say about using that piece of information?
You can't use it to find another piece
Why?
because you don't know if it's right.
Yeah, so, I mean, you can use it, but we didn't know if it was right. So last week, we were able to avoid using it. This week, you can't. You have to use it. There's no way you're going to be able to find C without using gamma. So that means if you get gamma wrong, what's going to happen?
You're going to get C.
You're going to get C wrong. You could still get B right. B has nothing to do with gamma. B has something to do with beta. And beta was given. All right? So it's still worth it if you get stuck to try to finish it because you could get partial credit. All right, so let's, we can pick whether we do B or C next. Let's do B. Okay. So we're going to find B. All right, first thing we're going to do is we're going to look at our table, and you're going to find the row that has everything in it. If you don't have a row that has everything in it, then you picked the wrong formula to solve this problem. Okay, it's not law of sines. So do we have a row that has everything?
Yes.
Yeah, what row?
The angle.
The angles.
Uh,
Oh, wait, no, A.
yeah, row A. We know A and we know
Oh,
alpha.
I thought you were going up and down.
So that'd be like a column.
Okay.
Yeah, so a row. So we have a row with everything in it. A is 4, alpha is 40. So that row just became very important. We're going to start with that. So you're going to take this part of the law of sines, and you're going to fill in what we have. Fill in the alpha, and fill in the a. Sine of alpha over a. So sine of 40 divided by 4.
And then wouldn't you do equals sine of 60 over b?
Yep, and since we're finding b, you want to use this part. I don't know why it keeps doing that. You want to use that part. Okay, sine of beta over b. The reason we're not using the third part yet is because we're not finding c. We're going to do that after. So we still need it, but not now. Okay, so sine of beta, which is 60 over b. Out of the 4 spots, number, 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 variable. Okay, you always want to have just one variable you're solving for. Okay. How did we say we solve a proportion?
Cross multiply.
Yep, we're going to cross multiply. We're not going to do anything out until the end. So you don't even need a calculator until the last step. So that's 4 sine 60 equals, and what goes on the other side of that?
b sine 40.
B sine 40. Perfect. Okay. Now the last step, we want to get b alone. How do you get rid of this times sine 40?
You divide.
Yep. Divide by
b.
Sine 40.
sine 40. So when you divide by sine 40, that's gone. And when you do it over here, that is your answer for B. Don't try to reduce the 60 and the 40 and think, oh, they're both divisible by 20. No, can't do that. Just type it all in just like that.
Type what in?
What's in that box?
To the calculator?
Yep. When we type it in, we're going to round to 3 decimal places. You also got to be careful, first of all, that you're in degrees. Okay, this week every problem is degrees. And it's 4 sine. And what did it do when I pressed sine? It made a parenthesis. I have to close it. If I don't, it will come out wrong. You need to close it right there because you are done with the sine of 60. Then divide by the sine of 40. And when you type it in, you should get an answer of 5.38. If you forget to close it, you will not get the same answer. That's a completely different answer. Okay, what it's doing there is this. 4 times the sine of 60 divided by the sine of 40. That is not at all what you meant. You don't want to do that. You want to do that. There's a big difference.
What was the answer?
5.389. 5.389. Okay, so now we know 2 out of 3 of the sides.
I have to find c.
Yeah, can we use Pythagorean theorem to find c since we know 2 sides?
Yes. Yes. Well, can
No.
we?
No.
That's my question.
I don't think so.
No,
because
then
it-
use the last part.
Why couldn't we?
Why couldn't we?
Oh, because you don't want to use something that you got the answer for. You want to use what was given to make it more.
But
right.
he said before that we want to do that.
So usually you like to avoid using things you were given, but there's no way to avoid it in this problem. With
Yeah.
B we did. B, we didn't use anything we calculated. So there's another reason though why we don't want to use Pythagorean theorem besides the fact we calculated that.
Is it because it's like a decimal?
Okay, it's also a decimal, so it's not a nice number to work with. Why else wouldn't we want to use Pythagorean theorem?
It's not 90.
It's not a 90, right? That's not a 90-degree angle, so that formula doesn't even apply. Right? It's like using your house key on my door. Good luck. It's not going to work. It's not the right thing for that calculation. All right? You can't use Pythagorean theorem when you have an 80. You got to have a 90. So we got to find C the same way we found B. Okay, so let's set it up to find C. Okay, when you set up law of sines, this is what I always do first. Sine, sine. I know it's going to look like that every time. Now, you have to pick a row that has everything in it.
B,
How many rows have everything in them?
A, and B.
A and B now. So you have a choice. Should we use row A or row B?
A
Yeah, why A?
is a prettier number.
Okay, numbers are nicer.
No, it's right.
We know it's right. Yeah. So we're going to stick with sine of 40 over 4 again. And now, since we're finding C,
It's gamma over C.
you need this part. Sine gamma over C. What's gamma?
80.
80. So that's something we calculated. We have to use it. And then over C.
And then you cross multiply.
Yep. So what I do is I usually do the cross multiply step in my head. Whenever you cross multiply, it's always going to be the product of the two that are numbers divided by the one that's on the diagonal with the letter. That's the pattern. So it's 4 sine 80 divided by the one that's with the letter, sine 40. If you don't want to do that in your head, you can do it out like we did the last one. That's fine. But any question why it's 4 sine 80 divided by sine 40? Okay. And because it's pretty much the same thing you just typed in, you can press second and then press enter. What that'll do is it'll bring up the last thing we typed in, like that. And we just have to change one number. What's the only thing I have to change there?
Sine 8.
The 60.
Change that. Change the 6 to an 8. If you want to retype the whole thing, you can do it that way too.
That's an 80, so make sure you get rid of the 0.
No.
What do I have to get rid of? 4 sine 80 divided by sine 40. That's what we want to type in. Any question on it? All right, and hit enter. And you get 6.128. Let's write that down. All right, just like when we solved right triangles, the biggest angle and the biggest side should always be together. Let's check. Yep, looks good. The smallest angle should always go with the smallest side. That looks good. And does anyone remember what we say about any two sides added together?
They have to add up to more than the third.
They have to be more than the third, any two. So if you add 4 and 5.3, you get 9.3. That looks good. 5 and 6 is 11. That's bigger than 4. 6 and 4 is 10, and that's bigger than 5. So any two sides added together have to be bigger than the third. If that doesn't happen, then something went wrong. Good. And that's a law of sines book. Any question on that? Now, let's try this one. This time they gave you a diagram already. Again, using 3 letters. Can somebody tell me what kind of triangle is that? And then we'll check.
Angle, side, angle.
That's angle, side, angle. So go back and check your list. see if that's one of the three types. Yep, angle, sine, angle, right there. All right, so set up your table. And which row did I say last time was this row is very important. It's
The one that are filled all the way?
the one that has everything in it.
That doesn't happen with this one.
With what they gave you, you do not have a row that has everything in it.
But we can
But you
solve
can
with
make
the
it
other
one.
angle.
But if you can still make a row that has everything in it, then this is still law of sines. Can we make a row with everything in it? Yeah. What can we figure out based on what they gave us?
The other angle.
Right. These two add up to 85. So what does that mean gamma would be? 95. Okay. Which row has everything in it now?
C.
C. But where did this piece of information come from?
We did.
Us, right? We found it.
So
you-
we have to use it?
Yep, so you have to use it. What that means is because you're going to have to use this row to figure out everything. If gamma is wrong, what happens this time?
And the rest, everything else is wrong.
Right, this time, everything would be wrong. Yep. Okay, so now we've got a row with everything in it. We can pick to do A or B first. Doesn't matter. Which one you guys want to do first this time?
A.
A. Okay. I'm just going to try to do it right over here. Okay, so first thing you can do, set up your fractions.
Sine alpha
Sine.
over A.
Sine. Yep. And we want to, if we're going to find A, we definitely have to use that. So sine alpha over A. Technically, it doesn't matter which side you put that on. You can put sine 45 over A on the left or on the right. It doesn't matter. But now, since the variable is on the left, you cannot put any more variables on the right. So what would we put on the right?
Sine 95 over 4.
So 95, that's a number. That's not a variable. Over 4, that's also a number. Perfect. Okay, so when we cross multiply, can anybody tell me it's going to be what times what divided by what?
A equals sine 45 divided by sine 95, or is it the other way around?
So the 4 is in there somewhere too.
No, that's right. 4 sine 45?
4 sine 45. So, yep.
Over sine 95.
And then you'd have to divide by sine 95. Yep. And there's your B.
Wait, so how do you know which one though goes with the 4?
The 4, because they're on the same diagonal.
Okay.
So it's, if you're going to do it out completely, it's 4 sine 45 equals A sine 95.
How can you tell which one's alpha again and beta?
And then when you divide each side by sine 95, that's how the sine 95 ends up in the bottom.
Okay, I get it.
How can you what?
How do you tell which one is beta again, like the 40 or the 45? I forget.
So in this one, beta is across from B.
Is it always across from B?
Yes.
Okay.
And alpha is always across from A. Yeah. Yeah, so that's a good question. I didn't explain that on this particular problem. But A is always across from alpha, B is always across from beta. Yeah. Okay, so now type that in and see what you get. 4 sine, remember close your parenthesis after you're done with the 5 for the 45 and divide by sine 95. It doesn't matter if you close it at the end because you don't have anything else you're typing. So that's fine. Okay, 2.839. Okay, so now this time we had an angle in the 90s. So can I use Pythagorean theorem to finish it?
No, because there's no 90.
It doesn't have to be in the 90s, it has to be exactly 90. That's not exactly 90. So if you use Pythagorean theorem, you'd almost be right. But that's still wrong. So don't use Pythagorean theorem on this one. Okay. All right. So now let's find B.
Okay, so after we do the cross multiplying, now that's like the last step right, before we just plug it into the calculator.
Yes.
Okay.
Yep. Okay, so what are we going to put on the left side to find B?
Sine 40 over b,
Sure, you can put that on the left.
and then 95 over 4.
And you're going to stick with the same side we were given because we know it is correct. Sine 95 over 4.
And then cross multiply, b equals 4 sine 40,
So 4 sine 40,
sine 95.
sine 95. Yep. Now type it in and see what you get. Again, I usually do second enter, then it saves me having to retype everything. And just change 45 to 40. Okay, so beta was a little bit smaller, so B should also be a little bit smaller. And it was. See, it's 2.581. So beta is the smallest angle, B is the smallest side, gamma is the largest, C is the largest. Yep. And any two sides added together will be bigger than the third.
Can you just go back down for a second? Sorry.
Okay, now that we know B, could we at least check our answer with Pythagorean theorem to see if we got it right?
No.
No, you can't use Pythagorean theorem, right? There's no 90. You can't use it. So if you don't have a 90, just take Pythagorean theorem and just throw it away. You can't use it.
That sucks.
Well, you can't use it and get it right. You could use it. Okay. Any question on how we got A or B? All right. So those are the first two cases. Right? So we've done angle, side, angle, sides, angle, angle, and now we're going to look at side, side. Okay. We're going to do part of this today. And then the rest of side, side angle we're going to finish tomorrow. Because side, side angle has some more things going on.
Alright, could you just go back to the answer for B really quick?
For that one, yep. 2.581.
Thank you.
Yep, no problem. Any other questions on the first two?
No.
Okay. Let's look at this one. So they gave us A is 3, B is 2, alpha is 4. So I put A on the left, which means alpha goes across from it on the right. That's B, so beta goes across from it. And C goes across from gamma. Okay, looking at your three pieces of information. Using the letters, what kind of triangle is this one?
Side, side angle.
Side, side, angle. SSA.
Not the other way.
Not the other way around. The way I remember this one is if you write it the other way around, this problem sometimes is a real pain in the, there you go. All right, so this one, that's how you can remember. This one can be kind of a pain. Because what can happen is it could end up being just like the last two. We try to solve it, everything works out just the way it did before. Or, when we go to solve it, everything has two answers instead of one answer. What do I mean by two
Is
answers?
it positive, negative?
They'll always be positive because we're dealing with sides and angles.
Like
Yeah.
reciprocals.
But when I say two answers, I mean you get two answers in that box, two answers in that box, and two answers in that box. So you end up with 6 total answers. If you end up with just one answer, that's exactly what happened in the last 2. One answer in that box, one answer there, one answer there. Or the other thing that can happen is you end up with no solution. That means whatever information they gave you, it's impossible to make a triangle.
That is lovely.
So that's the opposite of the 2 solution in terms of like how much time it takes. 2 solution takes twice as long. No solution takes half as long, right? Because it's half as long as like the problem we just did over here. Because you do one step and you realize after that one step, there's no solution. Now, as far as the information that's given, you never have to worry about what they gave you. What they gave you is done. You don't have to try to figure out, well, what could the other answer be for A? There is no other answer for A. A is 3, B is 2, alpha is 40. Those 3 things are
For
completely
this
done.
one, we have a row that's already filled out already by what's given. Is that like good?
Yes, because if you don't have a row that's filled out completely, you cannot use law of science. Maybe you could see now why if I gave you a side, and a side, you would not have a row complete. That's why law of science wouldn't work. Or if I gave you a side, an angle, and a side, you still would not have a row that's full. Okay, so we have a row that's full. That means it's law of science. We also have a row that's empty. Do we have any way to find anything in this bottom row right away? What do you think? Like, do we know 2 of the angles and we could add them up and get the third one?
No.
No. So because this row is empty, the bottom row, for now, you have to forget about the bottom row. It's useless. It has no information in it. It cannot be used to do anything. With law of science, you can use partial rows and you can use full rows. You can't use empty rows. Empty rows are no good. So that forces us into finding something first here. What is it we have to find first?
P or the beta.
Beta. Yep. You have to do that first. And then, once you know 2 angles, can you add them up and subtract from 180?
Yes.
Yes.
Yes. Then you can get this one. That'll be the second thing you find. Once you find gamma, you will have a partial row, which then allows you to find the side. So this is the order you have to follow in this problem. Okay. So let's find beta first. So set up your law of science. Okay. What are we going to put on the left side?
40 over 3.
Sine 40 over 3.
And then beta over 2.
And sine beta over 2. Before we go any further, I want to just look at that. What looks different about that?
There's the variables on the top.
The variable's in the top. Okay, we've never had the variable in the sine function before. Okay, the variable has always been the letter in the bottom. Okay, but not this time. Okay, so this time, you don't even need to cross multiply. Our goal right now is to get this alone. The only reason what's in that blue box isn't alone is that divide by 2.
Can't you multiply both sides by 2?
So all we have to do is multiply both sides by 2. And that's going to take care of getting the blue box alone. Don't need to cross multiply. You can, but it's going to be an extra step. So we have sine beta on the right. And we have 2 sine 40 over 3. Okay, leave it just like that. Don't do this out. Now, what are we trying to solve for?
Sine 3 beta.
So we're trying to solve for sine of beta or beta?
Beta.
Beta. So we got to get rid of sine.
Divide that.
So division will only get rid of numbers and variables. That's a function name. How do you get rid of a function?
Do the opposite of it?
You have to do the opposite
So
of the function.
No.
So cosine's not the
Okay.
opposite of
The
sine.
negative sign?
And what's that called?
The negative sign?
Reciprocal. It's not reciprocal.
Anybody remember what is that called? When you have the -1.
Negative sign, negative 1 sign.
Yeah, that's a great question.
Anyone remember? Caleb, you remember? Begins with an I.
What about you? You remember?
Did you tell us?
Oh yeah, I'm sure we talked about it.
You wrote it
Wait,
down
what's
on
the
board
second
number?
letter?
N.
Invariable, inverse.
Inverse. Yeah.
Look at
Do
it.
you remember that now? Inverse?
Yeah.
No?
Invariable.
So you have to take, remember you're not multiplying there, you are taking.
This.
Remember, because I kind of make a big deal of that? Just like here, if I said to solve that, you don't say multiply both sides by the square root. You say take the square root of both sides. Take. And the square and the square root are inverses, so they cancel. Well, same thing here. Take the inverse sign. Inverse sign and regular sign are inverses, so they cancel. And what's left on the right side?
Beta.
Just beta. And now on the left, you have to type that all into your calculator.
So that's what you do when you have this sign, both the signs on top.
Yeah, that's what you do when this is a variable.
So you just type in sign, the negative 1 sign.
Yeah, how do you type that in though?
Oh, it's the blue one, second.
Second. So second, inverse sign. 2 sine 40. Don't try to cancel anything on the left. Just type it in exactly like that.
Divided by
And then
3.
divided by 3.
Should you close it? Yeah, close the parentheses.
Yep. So this outer parenthesis, well, this one here and here, that's everything that's in the inverse sign. Yep. Okay, let me get rid of that. And we hit enter. Okay, when you hit enter, one of two things is always going to happen. You're either going to get an error, which means you either made a mistake, or if you didn't make a mistake, that the problem is not solvable. If you don't get an error, you're going to get a number. If you get a number, then that means the problem is solvable. Okay, so this one is solvable, and the answer is 25.374.
What's
But
the second one?
when I write that in the box, I'm going to put it up a little bit higher, just in case there is a second answer. So now there's two things we have to do. One, we have to figure out what the second answer is, and two, we have to see if it fits.
How did you find it?
So how do you find the second answer? How do you find it?
I'm asking you.
Oh, do you know?
No, I'm asking you.
Well,
I'm sure you know.
I
I
know.
probably do. You know?
Yeah.
Yeah?
Why don't you tell
I
us
don't
that?
think you know
Oh,
that.
I don't. So to find the second answer, you take the answer you got and you subtract it from 180. Okay, whether it's beta or alpha or gamma, well, that depends on what you were given in the problem. But the point is you subtract it from 180. And then, once you subtract it from 180, you have to see, is it possible to fit that angle that you just got in the triangle?
Wait, so that's what you do.
So you subtract your answer from 180, so what do we get, 25.374?
And
So I'm going to take 180, and on the calculator, since that's the last thing I typed in, or last thing that came up, you can press second, press the minus sign, and it'll automatically put in
see if
25.37.
it's possible to what?
So we have to see if it's possible to fit that number in the triangle. So we're going to scroll back up and look. So I took the answer that we just got, 25.374, and I'm going to subtract that from 180. I just did that right over there. When you subtract it from 180, you get 154.626. So if there is a second answer, that's what it would be. The question is, does that fit?
No.
Why not?
Because that has to equal 180, and we're already at 40
Yeah, what angle were we given?
or 40.
We were given the 40, so we know that that's in the problem. Can you fit 40 and 154 together?
Nope.
No.
Not
That would
gonna
end up
work.
as 194. The second answer this time is too big. Okay, so what that means, it tells you three things. It tells you there's no second answer here, there's no second answer here, and there's no second answer here. This is going to be just like the first two problems we did.
Oh, so there's no second answer for one of them, there's no second answer for any of them?
Right, they all have to either, they all do the same thing.
What happens if there was a second answer?
Well,
Then there wouldn't be.
if there's two answers here, then there's two answers here, and there's two
And
answers
so we would
there.
have to find both answers.
Yeah. Yep. So they either all have two, they all have one, or they all are no solution.
Yeah, I'm kind of confused. How do you know that number doesn't work? Like, doesn't fit the triangle?
So do you know how we got the 154?
Yeah.
And what angle were we given?
But what?
We were given the 40.
Okay, that's fine. I get it.
Yeah. So if you add 40 to the answer you just got, you're already at 194. That's too big for a triangle.
So what if it was like equal to like 130 or something? Would we have to find the other one to know first?
Well, if it, let's say it came out to 130, then you would be writing down 130 as your second answer right there. And then once we do that, we'd have two answers, and then I'd have to show you how to do the two here and the two here.
Okay.
So you'd have a total of 6 answers in this problem, 2, 2, and 2.
Okay.
This particular problem has 3 answers, because the second answer doesn't work.
So the second answer is one of your answers as long as the angles don't add up to over 180?
Yeah,
Okay.
yep. And that's what I have written down right here. So in this problem, if there was another answer, it would have been 154.626. But we were given a 40-degree angle to start. If you add the given to 154, that is greater than 180. Okay. So because the other answer is 154, it's too big. That's why it doesn't work. Okay, we are going to do one tomorrow where the other answer works. But for today, the second answer will not work. In any problem you do for homework, it's always going to have one answer. Okay, so now we found the second answer. Any question on how we found it?
No.
Okay. We ruled out that it doesn't work. Is there any question on how we know that as well?
No. And now we add up the 2 and subtract it from 180.
Right. Now we can get gamma. What do you get when you add 40 and 25 together?
65.
So we're going to subtract 65.374. That's alpha and beta added together. So that gives you gamma, which is 114.626. Now we don't have any empty rows anymore. We know something in the last row.
So now we can find C.
Yep. So now I'm going to do it right over here. We're going to find C. So it's going to be sine.
40 over 30.
So you want to go back to the row that was given, because we know it's right.
And then sine 114.626 over C.
626 over C. Yep. And when we cross multiply, what's going to be inside that box?
Sine 3 sine 114.626 over sine
3 sine 114.626 over sine 40. Yep. So except for having to check that second answer and realize it didn't work, everything else here was really the same as the first two. All right, so let's type all that in. 3 sine. We haven't typed this in yet, so we can't do second enter to save ourselves any time. We just have to type the whole thing in. Divided by sine 40. Well, I guess we had typed in the 40 before, but we had to type in the whole 114,626, so it doesn't save us much time. Okay, and that gives us 4.24 rounded to 3 decimal places. What would that be?
4.24.
One more decimal place. 4.243.
0.24.
4.243. Okay, always check. Biggest side should be with the biggest angle, smallest side with the smallest angle, and any two sides added together need to be bigger than the third. Looks good. Okay. Any questions on that? So these kinds of problems will pretty much make up half the test. Right? Because there's 3 answers per problem, there'd only be 3 of these on a test. One like this, one like that, and one like that. Okay? Those 3 questions would really be worth 9 questions because they take longer to do. Okay. And that's also why there's not as many questions in the homework. So the homework is 9 to 13. 17 to 21 and 25. And those are all odds. Okay, the 9 to 13, I think those are similar to the first problem. 17 to 21, that's like the second problem. And 25 is like the last one we just did.
What unit number is this again?
This is 4.2 part 1. And tomorrow we'll do 4.2 part 2.
And